Hello everyone, my name is Nachiketa and I'm the Technical Product Manager at Awiros. And in this video, I'm going to show you the journey of taking a computer vision model that's sitting on your local machine and convert that into a production ready video AI application that can run and deploy at scale with Awiros. So the journey looks something like this. Right now, let's say you could have a model which is good at detecting, let's say, three-wheelers and trucks in a given field of view. Now that's just a model that you run using a script on your local machine. But what do you do when you want to scale that application across multiple cameras, let's say hundreds of cameras running across a variety of servers of different configuration running on GPU and CPU and running using different video AI inference accelerators like TensorRT or DeepStream? As a computer vision developer, you do not want to have to worry about the deployment or the systems engineering part of a video AI application. If you're good at computer vision logic and deep learning model, you should be allowed to be kept separate from the systems engineering part. So now with Awiros SDK and tools, which I'm going to illustrate in this video, you can convert that computer vision model into a production ready video AI app in as less as 10 to 15 lines of code and then feature it onto our Awiros AppStack where it can be deployed and used by a global set of customers. This snippet which you're seeing right over here is that of the Awiros AppStack, which looks something like this, where you can see a list of more than 60 plus video AI apps for different use cases across a variety of industry segments which are ready to be deployed. And with Awiros, you can take any model you have and get it into a production ready app and get your application featured over here. But for now, let's start from scratch and go back to our developer environment. So now right now I'm back in my developer environment and I'm inside a folder called as Spira App Store, which is basically the folder which contains all my dependencies required to run an Awiros application. You get all of this by default as a developer, and to understand this directory structure better, we have our complete documentation where you'll be able to understand what different folders are meant for at docs.awiros.com, and in fact an entire guide of building a video AI app from scratch. But right now, since I'm gonna be illustrating this video, we don't need the documentation for now, but that is something you can use for your reference. So right now I'm in my App Store folder and my goal is to go from a model into an app. Right now I'm going to be working with a basic YOLO v3 model which is trained on the Coco dataset, for which I have the ONNX file over here by the name of yolovv3.onnx. So in the App Store there is a folder called as Awiros apps/apps which contains the source code of different apps which are currently running on the platform. You can see applications like fire and smoke detection, object detection, so on and so forth. Whenever you want to create a new app, you create a new folder for your application and write the necessary source code inside of it. So when I'm in my App Store, I'm simply going to run the command gin create app. Now gin is the utility that we have built that takes care of a lot of repeating functions of the developer, like creating an application, spawning different containers for running your applications in an isolated mode, checking the logs of different applications that are currently running. So you simply have to run the command gin create app and you are asked to enter the app name. So let's say I want to build a person detection app which simply detects the person in a field of view and sends an alert. So I enter this name and I get a message that a boilerplate has been generated. Now if I go to the Awiros apps folder, I'll have a new folder created by the name of person detection, which I can see over here. So I simply go inside the folder, I'll see a lot of boilerplate code that is generated for me, and as a developer I have to simply edit very few lines of code to actually get this application running. So if I go inside this code, you can see there are lots of pre-written lines which are basically initializing various modules that take care of the most repetitive function in a video AI pipeline. So for example, in each video AI application, you'll have to take care of decoding frames from a camera. In each application, you'll have to write some amount of code that takes care of initializing a deep learning model. You'll have to write some code that takes care of sending a given alert, a given metadata onto a UI from where it can be displayed in an interactive form to the end customer. You'll have to write some code that takes care of integrating your deep learning models with various inference accelerators like TensorRT and DeepStream. So we take care of all the system engineering and all the repetitive tasks in a video AI pipeline and offload it from the end developer. And if you see the run function, you can see different functions getting called over here, which are responsible for registering different modules, again, which I said, which takes care of certain systems engineering or certain repetitive tasks in a video AI pipeline. So for example, the init function over here registers a module required to initialize your camera over here, right, and registers various modules that are required to log your FPS every now and then. So and then you have a create primary model function being called, which registers a module to initialize deep learning models. Then you have the module called as person detection logic, which you can see over here registers a module called as person detection module, and that is getting registered over here. So the entire logic of the application is gonna be contained in this person detection module, and you can spot the run function of the person detection module class over here, and this is where you have to write your core logic of the application. And this is the only part in the code that you actually have to really tamper with. Then you can see a send event function getting called over here, which registers a module that is responsible and in charge of sending events at a certain frequency in the dashboard. And finally a play pipeline function over here, which, as you can see over here, iterates in all the modules defined so far and executes their run function. So again, as the developer, you simply have to write the logic of your application in the run function of your app module, which in this case is the person detection module. So right now I won't write the code in front of you. I've already written that, and I'll just swap the files so I can very quickly show you the only part in the code that you actually have to change. So I've swapped the files, and if I go back into the person detection.cpp file, and as I said, in the run function of your person detection module class, these 6 to 7 lines of code is the only real logic you have to write. So the logic is pretty straightforward, and some of the class names might be unfamiliar to you. You can go over this in our official documentation as well. But basically what we're doing is we're iterating over an object called as meta.streams, which basically represents different camera sources. So we could be deploying over hundreds of cameras, and what we're doing over here is iterating through each camera one by one. Over here is an if condition, which is basically checking if current blobs.size is greater than 0. So all the bounding boxes that your particular deep learning model detects, it's stored in an object called as current blob. And what we're basically checking is that whenever the deep learning model detects a bounding box, then iterate in all the bounding boxes detected in that particular frame and draw a rectangle over that. So you can see some OpenCV functions getting called over here, and all they're doing is they're taking an input frame which is stored in the variable called as aframe.frame. And what we're doing is we're getting the coordinates of the bounding box of the rectangle, drawing a rectangle around it. So this was the annotation part, where basically we are annotating a given frame with the detections that our object detection model is doing. After that, we're creating an object called as event, and what that basically does, it takes care of handling alerts and sending that onto the UI that a customer can interact with. All you simply have to provide it the frame that you want to be displayed on the dashboard. So what we're doing over here, we're taking the frame that we had annotated, and we are setting that as the event frame over here for the event that we just created, and we push that event into a vector of events, and that's it. Underneath the hood, it's taken care that all the events that you push with the particular frame, those are gonna be reflected onto the UI in a nice interactive way for the customer to view and sort through all those alerts. The rest of the code remains same. You can see again the init module for resting the camera. We have a create primary model function. So these are again some lines to initialize the deep learning based object detector, and the only change that the end developer has to do over here is to mention the kind of architecture that his model is going to be using, which in our case is going to be the YOLO v3. And to enter the actual path of the model, we can go into the header file called as person detection.h. So if I zoom in a bit, this is the header file, and again this is pre-written for the developer. The only change that he'll have to do is he'll have to enter the model path over here in the primary model file variable, and you can see we've given the path of the common YOLO v3 model that we just saw before. So again, I'll head to the main CPP file over here, and resuming the code, and see there is again a new filter function defined. What that does is it filters a particular object of interest out of lots of objects. So we're using the YOLO v3 model, which is trained on 80 classes. So out of the 80 classes, we only want to filter and send alerts for people. So that's what we mentioned over here. And again, as you can see, the developer simply has to call different modules, in this case an object filtering module, and under the hoods the logic for actual filtering, wherein you'll have to iterate through all the objects of the deep learning model and run an if condition and see if it matches the desired object. That's all taken care of. You simply have to call the module and simply provide an argument over here. The rest of the code remains the same. There is no change that the developer has to do. And once his code is written, once he has simply plugged in his model or app logic, we go back and we compile the code again using the gin utility that we saw earlier. So I simply have to run the command gin cmake apps, and then what I'm going to do is I'm going to make the apps by the command gin make apps. So that's it. It takes a couple of minutes and it's going to be compiled and ready to be deployed. So we can see that the app got compiled, and now all you have to do is you have to head on to appstack.awiros.com, where you'll have an option to register your app. So this is a form that the developer has to fill, and you simply have to enter the app name and some other details like the model information, the field of view information, the app logic, and so on. And once you do that, that app gets listed on the AppStack from where you can deploy it. So I've already done that process, so I'm going to skip that for now. So once the application has been registered, I can go on to the Awiros platform and deploy my application from there. So if I go on to the app orchestrator, which is basically a 2x2 grid which allows you to map any video AI app to any camera to deploy it, I will be able to select my application and start it. So in this app orchestrator, on the top row, you'll be able to see different video AI apps that a particular customer has subscribed to. So I can see the person detection and the pothole classification app over here. This can be any number of video AI apps that someone wants to deploy. And on the left column over here, I can see different video sources that I have onboarded over here. So these are different various public videos that I have onboarded over here, and an office video as well, just for testing purposes. So to start an app on a camera, it's as simple as selecting the corresponding cell and clicking on the start button. So when I click on the start button, in the backend, a particular Docker container is going to spin up, which ensures the application runs in an isolated manner. If I want to select some configuration, I can go onto the settings page over here, and I can select different app parameters like the score of the object detection model or different hardware accelerators that I want to use. Do I want to run it with ONNX TensorRT, or do I want to run it with, let's say, OpenVINO support, or let's say I just want to run it on GPU using ONNX. So again, all of this is something that the developer does not have to worry about, and I can already see some pop-ups over here which are basically alerts that I'm getting for a video that I ran my application on. So again, if I want to submit my configuration, I click on the submit button over here and I can go back onto the main page. If I want to stop an application, I click on the cell again and click on the stop button. And at a time, I can run my app on any number of cameras. So I can select, let's say, 3 cells and again click on the start button. So all the selected apps will run together. The cells have turned green, which means that the app has started. And I can see some pop-ups over here, which means I've started getting alerts. And you can again see that all of this orchestration and getting these alerts onto this dashboard, bringing the alerts on a pop-up like this, right, is something that the developer did not have to worry about. So this is taken care of by, again, Awiros in the backend and under the hood. So these are some alerts from our office video. Again, this is me in the video over here. So I can see all the alerts sorted according to severity, sorted according to the location. So I can see alerts of different cameras sorted for the customer to view. And I can see all the metadata together in the stats page with the number of alerts or number of alerts per location to get an idea of which location is most active and all sorts of metadata that I would possibly want from an AI analytics application. So all of this was just 5 to 10 lines for the end developer, and that is the beauty of building video AI apps with Awiros OS. So that was all for this video. In the future, we'll be coming out with many more videos on app development with Awiros OS.